Okay, let's go ahead and get started. So, once again, if we look at our calendar, of course today is Wednesday the 18th, and we only have one more day of class this week. That is the 20th. Now, that will be a quiz, and so I'm just going to send out the quizzes. I don't expect anybody to come to class, of course, not in person. And I want you to do those quizzes and send them back to me. So that's all that's going to be happening on Friday. Then next week, we meet Monday, and then that's it because Wednesday and Friday are both holidays for Thanksgiving. Then after Thanksgiving break, we have another Monday and a Wednesday, and that's it. Okay, so those probably not going to be teaching anything. For one thing, we're at the end, okay, but also I want to give y'all some time to just really get a whole lot done in Hawks before the end of the semester, you know. All right. The other thing I want to talk about today is when will our final exams be? So let me get this schedule for us. Okay. So we meet Monday, Wednesday, Friday at 9. So our final exam will be Tuesday, December the 8th at 8 a.m. Now, Tuesday, December the 8th, I'm just going to send out the exam and have y'all do it at home. So it'll be out by 8 a.m. for sure, but don't expect it to be exactly at 8 a.m. It won't be after that, though. It won't be any later than that. Okay. So, really, if we think about it, today is last day. Now, if there is anything else that I find that I really want to go over, I will, during one of those days that we have the next 2 weeks, we'll find a day and say, hey, let's go ahead and have a lecture today and go ahead and go over whatever it is. But again, we're kind of at the end of everything. So that probably is not going to happen. Today I do want to go over something though, something that Miss Lamar has probably already gone over, and that is Poisson distributions. So Poisson, of course it's French, so it has a very odd spelling. Okay, so Poisson distribution. All right, so a Poisson distribution is data that comes from a Poisson experiment. And it's just another one of our distributions, just like we can have normal distribution, binomial distribution, everything like that. But a Poisson distribution, like I said, comes from a Poisson experiment. So the way a Poisson experiment works is first, the results of the experiment can either be classified as a success or a failure. Okay, so whatever the thing that we're testing has to come out to be either, yeah, it came out to be true, or no, it was false. So success or failure. The second part is that the average number of successes is known. So we know the mean number of successes. We know the mean for how many times that happens. Then the probability that a success will occur is also proportional to the size of the region, so how big our data is. And the probability that a success will occur is an extremely small region, is virtually zero. Okay, so what does all this mean? Well, let me give us an example. So the example that I have here is the average number of homes sold by the Acme Realty Company is 2 homes per day. What is the probability that exactly 3 homes will be sold tomorrow? So let's think about this. Selling a home is either a success or a failure. You don't sell half a home, right? You sell the house or you don't sell the house. It's a success or a failure. Then, in this example, it also tells us that we know that the average number of homes sold is 2 homes per day. So that's our mean successes. We sell 2 homes per day. Now, just like every other probability, is that going to be how it works every single time? Is it going to be exactly 2 homes per day? Absolutely not. Sometimes we're going to sell 3 homes, sometimes we're going to sell no homes, and we don't eat for that day, you know? So what we're asking here is what's the probability that we're selling exactly 3 homes? Okay, so let's write some things down. First of all, we know the average number of homes sold in a day. We'll call that mu, because that's our average. And in this case, it's 2 homes per day. All right. Then we also know that we want to sell exactly 3 homes tomorrow. So what's the probability of that? So that's like the data point that we've been looking at with the normal distributions and the binomial distributions. Except in this case, x is exactly equal to something. With those, we were looking at, okay, what's greater than or equal to x, or what's less than or equal to x. This one, we're exactly equal to 3. We want to know exactly 3 homes sold. What's the probability for selling exactly 3 homes? Okay, and there's one more thing that we're going to need here, and it is something called a constant. We haven't really talked about constants so far this semester. This is probably the first one we've seen, and that is E. E is a constant called Euler's number, and it is about, if we round it, 2.71828. It's kind of like pi. You know how pi is 3.14, and then there's some other numbers that we don't really look at usually. E is a lot like that. It's another irrational number like pi, but of course its value is different. So we use 2.71828 for Euler's number. Okay. So now what we need to do is we need to plug this all into a formula that's going to give us the probability. And so here's the formula for that. We have the probability given x and mu is equal to Euler's number E to the negative mu times mu to the x all over x factorial. And I've just realized that I forgot my calculator in the office, so let me go get that real quick for us. Otherwise, ain't no way I'm going to be able to calculate this. Okay, sorry about that. calculator now, though. So let's go ahead and plug in our values for our variables. First of all, this is what we call a function. This is the name of the function. It's basically telling us first what we can expect to get out from this. And then in the parentheses here, it tells us what we need in order to get something out. So we need x and we need mu. Okay, so this is going to be p of 3 for x and 2 for mu. Okay. And so let's see, E is just going to be E, so 2.71828. To the negative mu, so 2, negative 2, times mu 2 to the third power for x, since we want exactly 3 successes. And then we have x factorial on the bottom here, so 3 factorial. Okay, so let's start simplifying some things down here. 2 to the third power, that's pretty easy to do. It's 2 times 2 times 2, that's 8. So times 8. And then 3 factorial is also pretty easy to do. That's 1 times 2 times 3. So 1 times 2 is 2. 2 times 3 is 6. Okay. Now another thing that I can do is that if I see any common factors, I can go ahead and eliminate them. It's not a necessary step. If you were calculating this entirely by hand, it would help a whole lot, but I'm definitely going to put this part into the calculator. But I'll go ahead and do that for myself. So I see that 8 and 6 both share a common factor of 2, so I'll go ahead and divide them both by 2. Okay, so 6 divided by 2, it leaves me with 3 on the bottom here. And 8 divided by 2 leaves me with 4. Okay, so let's figure out what e to the negative 2 is. Now luckily there's also an e button on this calculator. E to the negative 2. Okay, so e to the negative 2 is about 0.135335. That's times 4 over 3. So times 4 and then divide by 3. We get that P of 3, 2 equals 0.180447. Okay, so there's our probability of us selling 3 houses if the mean is 2. Okay? So the probability in this case is about 18%. Not a whole lot of room there for us to make this happen, but it is possible. Okay, so any questions here? I'll pause for questions. Okay, I'm not seeing any questions. Of course, if you come up with one, just type it into the chat and I'll get to you. I'm not seeing any questions right now, so I'll go ahead and move on. And next example is a little bit different. We can also do cumulative probabilities. Many of the probabilities that we've looked at over the semester can be cumulative, and Poisson is no different. So the example that I have here is, suppose the average number of lions seen on a one-day safari is 5. What is the probability that tourists will see fewer than 4 lions on the next one-day safari? Okay. So the average is 5, but we want to know what the probability is of these people seeing less than 1. So let's think about what these probabilities look like. Again, they're discrete probabilities. So what we've got here is kind of like a normal curve, but not quite the same. Okay, so what we've got here is like a curve that follows these discrete variables. So maybe one success, so maybe, like 1 lion, 2 lions, 4 lions, 5 lions, 6 lions, 7 lions. Okay? So what we want to know is, what is the probability for 1 lion, 2 lion, 3 lion? I'm sorry, 0 lions, 1 lion, and 2 lion, and 3 lion, because we're looking for less than 4. So we've got to add up all of these places here. In other words, we're going to have to do more than one Poisson calculation. So once again, we need to write down our information. We know that we have a mean of 5, and our x in this case, we want less than 4. So we need to calculate for all of the numbers that are less than 4. That is 0, 1, 2, and 3. And then, of course, we need e as well. E is just e. It's 2.71828. Okay. So again, we're going to have to do multiple Poisson calculations. We're going to have to do one where we plug in x equals 0, another one where we have x equals 1, so on and so forth for all of these numbers, and then add them up. Okay? Now we also, on here somewhere, if I can find it, variables. Oh, there we go. Also on here on the calculator, we have Poisson calculations programmed into here. Okay, so you just tell it, okay, what's my mu value? Well, in this case it's 5. What's my x value? Let's do 0. We can go ahead and paste that to the home screen, hit enter, and it will give you the value. Okay? So that's nice. So if you have one of these TI calculators, or a calculator emulator, or one of the downloads on the Apple Store or Android or something like that, then you can use that to find your Poisson. So I'll just go ahead and record that real quick. When I plug in a 0 for x and 5 for mean, I get 0.00674. Okay. Whoops. All right, so we got that one. I also need P where x is 1, P where x is 2, P where x is 3. And I'm going to go ahead and use the Poisson function in the calculator to find these. So let's see, where x is 1, we get 0.03369. Okay, where x is 2, we get 0.08422, and then where x is 3, we get 0.14037. Okay. So something I want y'all to notice, remember that our mean is 5. As we plug in numbers that get closer and closer to our mean, as we plug in x values that are closer and closer to our mean, the probability gets closer and closer, or higher and higher. So it increases as we approach that mean. Okay? And that makes sense. If the average number of sightings for lions is 5 in one of these safaris, well, what's the probability that we're going to see 500 lions? It's there, but it's minuscule. If we get closer and closer back towards 5, though, since that's probably what is going to happen, the probability gets closer and closer to 100%. Okay. Now, all of these we need to combine into one probability by adding them in order for us to see the probability of seeing 0, 1, 2, or 3. Okay, so we need to add all these up. So 0.00674 plus 0.03369 plus 0.08422 plus 0.14037 gives us an overall probability of 0.26502. In other words, if we convert that to a percent, it would be a 26.5% chance of seeing less than 4 lions. Okay. Any questions? Again, I will give y'all some time to possibly ask questions. Okay, I don't see any questions. So again, Poisson is for when we have a question or an experiment where the outcome can either be a success or a failure. And we also know the average number of successes. And so then we can ask ourselves, okay, what's the probability of this happening? So the formula itself, we need to have mu, which is the average number of successes, x, the value or the number of successes we want to happen, and e, which is a constant, Euler's number. The formula is really pretty simple. We have e to the negative mu, which easiest way to do that is in your calculator. Mu to the x, which you could probably do yourself, and then x factorial, which also you could probably do yourself depending on what x is. But it's just plug in those numbers and see what you get. Multiply these two together, then divide by that one. So I'm not too concerned with us on this. So again, Friday we will be having a quiz. That quiz is going to go over Poisson, and it's also going to have some approximations for binomial distributions. So remember what we did on Monday was we took what we know about normal distributions and used it to kind of guess at what a binomial distribution would be like. And so finding the area. It's the exact same thing that we've been doing with our z-scores. It's just we got to check some things before we start plugging things into a z-score. All right, but I think that'll do it for today. So I will see y'all. Wow, when will I see y'all? I don't know that I will. Again, if I come up with something that I think we really need to go over before we hit the exam, then I'll have another lecture. But for right now, what I want y'all to do for the remainder of the semester is just work on Hawks. Get as much of that done as you can, because that should help you do a lot better on the final. All right, but that's it for today. I will see y'all later, hopefully. Have a good day.